How often does a system need to be resynchronized under normal conditions? Once an hour, once a day? What's the frequency of that?
So we can talk about timing, synchronization, and polarization. Both of these has to be considered. With timing synchronization, if it's a fiber link like we talked about, 50 kilometer or so, and it's aerial, and even if it's underground, continuous synchronization is required. If we consider GPS clocks that are used as global clocks, but we only want to perform corrections to the synchronized clocks because there are drifts in the fiber. We've seen that with 14 kilometer like link distances, this could occur every once in few minutes at the best case, but even maybe faster than that, depending on the deployed system. Uh, Once in few seconds is generally definitely needed for realistic link lengths, say few to tens of kilometer. And we have seen examples in today's talk where this was in fact done in a continuous manner by sharing the reference itself from the source node to the end node. So it's a continuous clock recovery that's occurring at the end nodes. When it comes to polarization drifts, really depends on the deployment again, but we can state that there are examples that we talked where once in 20 seconds, the routine for compensation has been started in a 34 kilometer link. And this was in New York City. So that gives an example of a case where periodic compensation was started every once few seconds. But there are also systems where a metric is used in order to determine, okay, if this metrics drop below this threshold, then we start this routine. Until it approaches that threshold, we are fine. We just wait for the system to continue running, and we don't have to trigger any sort of compensation routines. So that's the approach that could help probably keep the system active for longer as well. So both these can be considered depending on how fast the drifts are occurring in the system.